Okay, we're going to start the next program by Adam. The title is Unleashing Chaos, the key to bulletproof resilience in DevOps. Please.
Thank you for the introduction. And let me welcome you all on probably the last session at this on this day. And my name is Adam Balazs. I'm from Hungary. I'm a senior SRE engineer. And today, in the next 45 minutes, I would like to talk about chaos engineering, how chaos engineering can help with resilience, and how chaos engineering can help with anything else other than resilience. Just a little bit about myself. I've been in the IT industry for about 10 years. My roles have varied from being a network designer through a cloud engineer to being a platform engineer, and right now being an SRE engineer. So I've seen a lot. Moving to our agenda, today we will try to discover what is the problem with the pre-prod assumptions versus what's the reality like. Then we will talk about what is chaos engineering. Then we'll move on to how chaos engineering evolved from scratch to wherever we are right now. Then I will introduce you to some of the chaos engineering tools that you can use and that you can leverage in your environment. Then we can move on to chaos engineering game days that most likely you will be using, and then a summary of all of it. And if there is time, then I will try to demo one of these chaos engineering tools with a flashy GUI and what it can do, for example, in your Kubernetes cluster. So let's start in a far away galaxy with a Death Star. I'm pretty sure most of you have seen the original Star Wars movies, and you remember that the Death Star was built with one purpose, that it is indestructible. And if you remember, it was destroyed. And it happened because, the CEO, the emperor, thought that it is indestructible. We have no vulnerabilities, and we don't have to test. We don't have to do drills, and we don't have to do this and that. However, some smart guys found out there's a workaround, and they used the exhaust port to launch a rocket or missile, and eventually they destroyed the Death Star. Now you can think of the Death Star as your production environment that would be also destroyed in the same matter if you wouldn't do drills, if you wouldn't do chaos engineering, if you wouldn't test. And it can only happen because your infrastructures, your applications, your services, your company is based on one word, which is assumption. You assume that your service is 100%, it is bulletproof, but the thing is, it isn't. I'm pretty sure you do a lot of testings in pre-production environment, in your dev, in your QA, in your engineering. But the problem with those environments that they cannot mimic what is exactly happening in the production environment. So that kind of user load cannot be mimicked. It cannot be recreated. Those kind of third parties, those kind of cloud providers, your service providers, they are giving you different kind of SLAs. And sometimes they cannot even stick to those SLAs when there is a bigger outage going on, like a regional outage. So this is important. That is why it is important to test your stuff in production. And the tool, the principle, the culture, or however you want to call it, is called chaos engineering. And chaos engineering is used mainly for one purpose, to test in production. I would like to start with a brief history about this topic and how it started. As you can see on the screen, I hope you can see it. The year is 2011, but this is probably not correct because there are some urban legends which says it all started way before that. when Netflix moved away from data centers, so from physical servers, physical appliances, just to the AWS cloud. And before the AWS cloud, they did some use cases, they did studies, they did some tests, but when they switched off their data centers, I'm not saying everything crashed, but they had a lot of complaints. They had a lot of phone calls from the customers that, we cannot watch this movie, we cannot watch this TV show because it is lagging. It's not even loading. I don't even have my movies, which I want to continue to watch. So Netflix went to AWS and asked AWS to switch off one of their regions, shut down one of their regions because they want to test their resilience. And of course, AWS said that they cannot do it because we have other customers to take care of. So what Netflix did, they told their engineers to come up with scripts, come up with certain scenarios, come up with playbooks, rule books, because we want to test regional outage. And the impact of that test was huge. Other companies, they also picked up on this and they wanted to do the same. Obviously, in the beginning, Netflix didn't make their tool, which was called Chaos Monkey, open source. But after a while, they decided that Chaos Monkey can be open sourced, and other companies can also play with this amazing tool. Afterwards, chaos engineering has become a discipline. After that, huge enterprise companies like aviation companies or companies in the banking and finance area, they even launched their own chaos engineering department. They hired engineers who were only focusing on this discipline. Books have been written, chaos comps have been started, and they've been going on since then. As you can see on the next picture, on the second picture, Gremlin. Gremlin is probably one of the most known tools when it comes to chaos engineering. This is a tool that can do it all. It is not free, but it's probably the most powerful tool. Then moving on to the next picture, that's an AWS service, because what happened after Chaos Monkey and Gremlin was created, the cloud providers, they realized there is a market, so there is money in this business. So GCP, Azure, AWS, they all came up with their own chaos engineering service. What you can see on the screen, it's called a fault injection service by AWS. I think it's pretty straightforward. When your infra is in AWS, then probably this is a tool that you want to use because it has preloaded experiments, preloaded tests, preloaded risk analysis. And of course, you can leverage the whole AWS like monitoring suite for that to check your metrics. Now moving on to 2023, that's when AI and ML and Gen AI became a huge thing, and all these tools are using machine learning. I wouldn't say AI, but machine learning to work on their hypothesis and work out the what can happen, what could have been happened. All right. So now we have discovered chaos engineering. Why does it exactly matter? And nowadays, as you know, that every company wants to have their application, wants to have their service to be available for their customers 24/7. It doesn't matter, just even like a 1 minute downtime, 10 minutes, one day, it can cause a huge damage in the customer's reputation. So you wouldn't think that, but yeah, even these small downtimes when the applications or the platforms are not reachable, that can cause a huge damage, because people can post it on Twitter, then other social media platforms picks up, and then it's all over the internet. Then XYZ company wasn't available for half an hour. Just imagine when you cannot access your Meta suite. That's one example. Tooling landscape. So what kind of tools you can use to start your chaos engineering journey? As I mentioned that all the big cloud providers, they have their own toolkit. Azure has what is called Azure Chaos Studio. AWS has the fault injection service, and actually GCP doesn't have its own chaos engineering toolkit, but it is using an open source toolkit. That's the logo of that toolkit. I already talked about Gremlin as a third-party tool. Yeah, that's probably the most well-known one. And also Litmus. Litmus is getting more and more popular, and Litmus is a great tool if you have your matured CI/CD pipelines and you want to do some automation as well, not just your regular drills, regular tests on the GUI, but actually have your CI/CD pipeline pick up these chaos engineering experiments and run them, on a regular basis, like on 3 p.m. on a Friday. And as we move on to the next one, as you can see, it's a Kubernetes, because Kubernetes is somehow it's very important to everyone. Then there are chaos engineering tools that are focusing on, especially for Kubernetes clusters. One of them is a Chaos Mesh, and the other one is a PowerShell. So all these tools are excellent tools if you want to start out. Some of these are completely free, so you can use them to test. Some of them are available for a free trial, just like Gremlin. For 30 days, you can do whatever you want in it. You can explore it. You can use it with your any kind of services. So where can you actually use chaos engineering? Infrastructure. It is quite straightforward what you can do in your infrastructure with these tools. You can inject network latency. You can cause regional outage. You can kill some of your virtual machines. You can screw up your auto-scaling groups. You can, you can mess with your IAM settings, so all that. Applications, well, you can test your microservices. You can test your, even your metric endpoints. Kubernetes again. That's a tricky one, because you wouldn't expect chaos engineering to be used in Kubernetes, because as we all know, all those pods, all those nodes, they are self-healing. But if you want to validate that your settings, that your policies are correct, then chaos engineering, got you covered. So you have your tool, you know what is chaos engineering, you are excited to start out, but you have no idea how. But there are 4 very easy steps how you can start this journey. The first one is when you want to define an objective, why you want to run your chaos engineering experiments. But probably the most important thing why you want to do that is to check how bulletproof your infrastructure, your application, your security, your Kubernetes cluster, and all that is. I've already talked about hypothesis. That's very important when you're defining your objective, that you must have a hypothesis in your mind or in your rulebooks. Then whenever something happens to your infrastructure, then this and this and that is going to happen. So for example, if your primary database goes down, then you know that in 2 minutes, so in 120 seconds, your replica should pick up the load. And with chaos engineering, you can test that, for example. Next, starting small is key here. It's very important because, as I said, the whole idea behind chaos engineering is that you are testing in production. So you want to make sure that when you are testing out your journey, you're not causing a huge trouble. You are just doing like small steps, like baby steps. Killing a virtual machine, it's not going to hurt, most probably. Automation. I already mentioned the Litmus Chaos as a tool that you can use for automation in your CI/CD pipeline. And actually, you want to get to that point where you can automate your chaos engineering journey, your experiments, your scenarios, or whatnot, because that's a pretty good tool that you can use in connection with your disaster recovery drills. So, with your disaster recovery drills, you validate a set scenario, a playbook or a runbook, or however you call it. And when you use it in connection with chaos engineering, you can even make sure that you have the preventive steps. And measure impact. That's something that normally people don't really think of, because they only think that you can only learn from your mistakes, but that's wrong. So whenever you are measuring your the impacts, whenever you are measuring you're checking your logs, you're checking your Grafana dashboard, and or even your Minikube dashboard, or your monitoring solutions in the cloud. Even if your experiment was 100% success, maybe you want to check that why it was so successful, and you want to share it with other teams, or you want to share it with your stakeholders, or whoever you want to share it. So you can also learn a lot from those experiments as well. Yes. So game days. Game days are, I would say, a very important part of the whole chaos engineering discipline. And even though if you are not going to go into down in this rabbit hole, which is called chaos engineering, then probably game days is something that you can leverage. When you are doing disaster recovery drills, those are always planned. So maybe you get all your teams together, not just your engineers, but even your devs, your operations team, your SREs, your SOC 2 team, or even your business analysts or whoever is involved. The main idea behind the game days is that these drills, they are unannounced. So obviously you are going to talk to your squad leaders, your team leaders, that on this and that day, there will be an unannounced drill, and please make sure that XYZ people, they are available, because we will be running this. So we will need them to be present, because if something goes wrong, we need them to fix that. And then you all sit together for the planning session, and then you all come up with the scenario, the hypothesis, and you work out a game book for this. So you can think about even like as a board game for the game day. And obviously the goal will be to test the system's resilience, to test its vulnerability, and improve on the response strategies. Why game days matter? Well, here I tell you a story about my history of mine. So I was for 10 years, I was a firefighter on ships, on cruise ships, and we did drills regularly. So on every week we had certain drills, sometimes even dry drills, when we played out scenarios on just a piece of paper. We did that in a confined area when it was just us firefighters. And after certain events that happened in the shipping industry, the maritime law became that you have to do these drills unannounced sometimes, and even the guests are involved who are on those ships. So we started to do those drills, and the guests were involved, and we got different scenarios every time. And the rate of those ship accidents started to fall down, because the people who were responsible for these security events, for these safety events, they already got it in their muscle memory, and they already had confidence how to do this when something happens. So if 2 a.m, you hear the alarm, there is a fire somewhere in the bakery or somewhere on the ship, you don't think, you just act, because you know what to do. This is why game days matter, because basically this is exactly what you do. You do these unannounced drills, and you test your team how fast they can react, how fast they can defend, how fast they can mitigate for example, the cybersecurity attacks. Because yes, you can have pretty good playbooks for these occasions, But what happens if your alerting system is not in place and you detect that that cybersecurity attack like 5 minutes later than you were supposed to? Then it's already too late. And with chaos engineering, that's what you do. How to run the game days? Well, I kind of explained it. You plan it, you communicate it, and then you run it. And then at the end, you can do a postmortem. And during the postmortem, you can discuss all the feedbacks, all the metrics, what went wrong, what was great, where we should focus on, what should we drop, these kind of things. Case study reference will be the demo towards the end. So I will just move on to the next slide, which is where you can transfer these principles that we are just talking now. Probably the first one would be, which is the most important, I think, that's your business continuity plan. Because I don't know if you have ever heard about the butterfly effect. So when the butterfly flaps its wings somewhere at the other side of the world, that can cause like a chain effect or a much bigger effect than at the other side of the globe. And this is based on that. So even if a small things, a small error happens in your application, in your infra, that can lead to a much bigger. And business continuity plan is based on how you can mitigate these errors, these failures, and how resilient is your system. The next one would be your disaster recovery strategies. And actually, this is something that I deal a lot in my job as an SRE engineer, because I'm responsible for the security and compliance part of it. And it is very important to have a very well planned, very well structured disaster recovery strategy. So not just your playbooks are in place, but also your the chain of command, also the your escalation policies, and how regularly you audit your escalation policies, for example. Because if there is someone in that escalation policy on a level 2 or level 1 side, and for example that person is not even with the company, then you are kind of screwed because you haven't checked your escalation policies for a while. So disaster recovery strategies are important, and sometimes they can be based on these chaos engineering experiments, because you can even discover these, or which is even wrong, you can discover that one of your playbooks has a mistake in it. Because, for example, your prod environment is not even called like that anymore, and you have a new SRE engineer who is following the playbook, and he or she's still looking for the old name, and cannot find it. And by the time they figure out where to find the new name, it can be too late. Crisis management and team preparedness, that's also a key component here in the principles, but I already covered it. And the fourth one would be building a culture, which is based on these adaptability, how your team can adapt to these new changes, to these new scenarios. You can only achieve that by running more and more scenarios and making your team more and more confident in that what they're doing. Some key takeaways. So chaos engineering is not, how to say, it's not just about creating chaos. If it was just about creating chaos, then it's pretty easy, because you can just ask your junior devs to work in prod, and I'm pretty sure they can create enough chaos. So it's not just that. It's how you can work with the data, how you can work with the information that you get from those scenarios, from those experiments. The next one, as I've said it like many times, testing in production instead of testing just in pre-prod. So I'm not saying you should stop testing in production, because that would be a stupid idea. but you should emphasize that testing real life event can only be happening in production environment. And third one, resilience. This is built through proactive experimentation and learning. So as I said, again, just do these, run these experiments, run these scenarios as often as you can, and focus on the information that you gather from these, because these are the metrics, these are the informations that can help you to, to make your infra more secure and make it more resilient. Now, as we still have time, I would like to move on to my demo. Let me see if I can make it bigger somehow. Just okay. Just a second. I can't find my mouse again. It's gone. Oh, okay. Can you see it? Oh yeah, it's here. Okay, let me pull it up here. Okay, so probably you can see it now. I just ran a very simple spin up a very simple Kubernetes cluster on Minikube. As you can see, there are 3 engines pods running, and you also have your Gremlin pods, because it will be Gremlin that I would like to showcase you, because I'm not saying that's the most powerful tool and that's a tool that you should use, but this is something that can showcase you what chaos engineering can do and how you can start out with it. So let me switch over to the Gremlin user interface. Yep. All right. Okay. I'm not sure if it's big enough, if it's visible. Yeah, probably like this. Okay, it's just I cannot see it. Never mind. So this is the Gremlin interface. When you sign up, when you log in, this is what you are going to see. If I go to the scenarios, I already created a scenario for us for this demo day. It's a very simple scenario that in my Kubernetes cluster with the Gremlin tool, I'm just going to kill all 3 pods, all 3 engines pods, and we can see on the Minikube dashboard that how they will, self-heal. So what you can do here, oh no, sorry, actually, yeah, my bad. This is the services tab, which is even cooler than what I was talking about. So with the services, which is a new add-on to the Gremlin. So with the services tab, what you can do is it tells you through a pre-built risk analysis, then what kind of tests, what kind of experiments you should run. So if I scroll down, it will tell me that something regarding to my CPU usage and my memory usage is not correct. So it is telling me to run these experiments. And which is even cooler, if I click on the CPU and if I scroll all the way to the down, all the way to the bottom, then if I click on the to do, okay. Okay, well, actually, yeah, I have no idea. It should be showing you that in the Kubernetes, in your deployment manifest, which modifications you should do in order to fix this problem if you are having any errors in your experiments. So when you will run this and when it's connected to any health check, or if you have a health check probe in your deployment or a liveness readiness probe, then you can monitor the health check here as well. So going to the scenarios that I actually wanted to show, that so if you come to the scenarios here, where you can configure them, where you can create new ones. If you just go to mine, then you can see I just created the shutdown, the pods, and you can even tell how many pods you would like to shut down. So if you'd like to just kill one of them, or if you like to kill all of them and watch what is happening, then you can also do that. But if I want to modify the whole thing, then I can show you what else that you can do as well. So here you can define your cluster, your namespace that you are working in. It is showing the 3 pods, the 3 Nginx pods. And as you can see, I just configured it to all of the pods should be killed, should be shut down. But if you like to measure something else, let's say just the resources, as we talked about the CPU and memory, you can also do that. So you can, as you can see, CPU, disk, memory, or any IO, or even networking, anything regarding to networking. So let's go back. So if I just cancel this, and if I run the experiment, run the scenario, then you should see here that the top 3 pods, the Nginx pods, they should be giving you an error and they should be self-healing soon. Yes, there's an error. So as you can see, they are automatically self-healed as they were intended to. However, if your deployment manifest is not correctly configured, it's not correctly set up, then obviously these pods wouldn't have come up in a second. They would have struggled to even be rescheduled. And what else I was talking about, the game days. So Gremlin also gives you a separate interface for game days, where you can define the goal, which is the hypothesis, as I already mentioned that. You can define your environment, whether if you're running this in pre-production or whether if you're running this in production. Because if you're running it in production, then it will send a notification to not just the engineering team who is involved, who are members in this Gremlin subscription, but it will also notify the managers that your team is running this this type of scenario in production environment, and there might be disruption. And we talked about runbooks, so you can just include your runbook in this, and Gremlin will pick up all the important information from that runbook that can be used for this for that scenario. So let's say if you are doing this in a Kubernetes cluster and your runbook is defined for that, then Gremlin will pick up the most important information from that, and we'll check the outcome of your scenario against those against those what is defined in the runbook. Participants, that's pretty straightforward. You can define who is joining to this activity. And all the other tools, all the other menus, as you can see, they are very straightforward. You can monitor what kind of runs you had, what kind of runs are already scheduled, so you can plan ahead. And actually, that's the end of my presentation. So if you have any questions, then feel free to ask.
Thank you. So imagine a situation that your test automation, I'm doing test automation, and imagine a situation that your test automation is really good. You have been testing it very well and you go live on production. What are kind of examples of bugs you didn't notice in advance and will show up in the production? So in other words, what makes what is it called again? Engineering, chaos engineering. Thank you. What makes it the added value? Like what kind of bugs?
Yeah, as I said, with chaos engineering, you test for something unexpected, something that can only happen in real life. So when you do test automation, you do you create like a unit test, for example, and you are test just one part of the code, one part of that application. But with chaos engineering, you test anything that is involved in that application, in that service, and whatever is even connected to that service.
And then basically you're talking about the whole chain.
Yeah, exactly. Yeah. Exactly.
And if you compare to like a chain test, now this week, basically at my company, they're doing a chain test, but I'm not here. I'm not there because I'm here. And even like a chain test in a non-productional productional environment, it has differences, basically.
Well, I'm not familiar with chain tests, so if you can elaborate on that. So what's the what do you mean by that?
Yeah, like the difference between like if you're gonna do a chain test before you go live on production, what is then the difference between a situation on production? Maybe, for instance, for endpoints that before production they can handle like an amount of CPU, but maybe in production that it can be different, or
in production it can be definitely different. I mean, you as I said, you cannot mimic that kind of user load that you are expecting. Actually, that's the thing; it's unexpected. So that kind of user load is unexpected. So maybe when you are testing against your API with a Postman or anything, even like that, even like so, you cannot mimic that because you don't know what to expect. That's the main difference, exactly.
Okay. Thanks.
When it comes to running chaos tests, you said you define a hypothesis and then you kind of work against that. How do you know when you've gone far enough? You were saying that it can go well and then you can do a post-mortem afterwards and say, oh, we didn't take our system down. But how do you know that you haven't gone into the realm of doing something that is unexpected but also unrealistic, like delete all of my databases and then wipe the drives and throw away the servers? And how do you make sure that you haven't gone too far and you've gone far enough for it to actually be effective and, as he was just saying, a value add?
Yeah, absolutely good question. I can give you a very good example to that. I don't know if you remember what happened last year or 2 years ago in Africa regarding to Asia, when the Houthi pirates they cut the cable, the internet cable, the sub level cable, so it was cut by the pirates, and the whole Africa region was down, and all those companies, all those enterprise companies who didn't have a very good structured disaster recovery plan, disaster recovery strategy, and business continuity plan, basically they had no idea what to do. They were just running around like headless chickens and figuring out what's the best method. Do we fail over? Do we bring up new instances somewhere else, or how do we move on from there? So this is, for example, something which is very, very unlikely to happen.
I guess then how as a company would you make the decision to do something? Because I mean, I don't think anyone expected the Houthi pirates to do that.
Yeah.
And obviously, as after that, people were considering and everything else. But on a day-to-day sort of basis, how would you advise a company to figure out what level of chaos engineering is appropriate versus the investments? Because something like assuming that the Houthi pirates are going to do this is, at a certain point, what do we say about like if a meteorite is coming towards Earth, how do we manage it? So I guess I'm wondering in there, how do you figure out as a company what's an appropriate level of chaos to inject into your system?
Well, again, that is still a very good question. I guess you just need to measure your most important metrics, your most important KPIs, your most important SLIs, SLOs, SLAs, and to create a plan towards that, against them, and test those. And then you can move on to something like the security measures. So, for example, like DDoS attacks, brute force attacks, cross-site injections, or you can even do something like compromised service account, which can also happen any day. And you can measure that, how your policies are in place, how effective they are, whether they can prevent that service account to do more damage as it's supposed to do, or not supposed to do, actually. So these kind of things.
Okay, thanks.
So you showed this tool Gremlin, right?
Yep.
Disabling or shutting down an entire pod of yours. How exactly is Gremlin doing that? Is there like an API or a token it's using to connect to the Kubernetes cluster, or like how's it authorized to do all this?
Actually, if you look at the screen, there should be a Gremlin pod, 2 Gremlin pods. So when you install, when you add your, for example, you are using Helm charts to deploy your Kubernetes cluster. You add the Gremlin repo, and the Gremlin repo will add those Gremlin pods, and that's how you authenticate. It's pretty simple. You don't have to do anything else.
Okay, thank you.
So everything is done behind the scenes. Actually, to set up this kind of cluster with a Gremlin and to create a Gremlin account, it takes probably like, I don't know, 5 to 10 minutes. Definitely not longer than 10 minutes.
And the Gremlin pods will be connected to Gremlin servers.
Yeah. Gremlin will pick up. So on the Gremlin menu, you see something like agents, and from there you can switch to whatever agents you are working in. You can work with them. You can work with Gremlin in AWS as well, for example, if you want to.
Thanks.
Okay, I think the time's running out.
Yeah.
So, yeah.
Well, thank you, everyone.
Thank you. Thank you. Okay, so today from 5, we're gonna have the closing keynote with Dana and Alex's interview, and it'll be held here. So if you are, I don't think no one's gonna listen in Japanese audio here in this room here, but Japanese audio will be in this room. And if you want to hear it, listen in English, you come to this room from starting from 5 p.m. Thank you.